So this is a lecture on the metric system and the conversions between the same type of units. So let's just start with the idea that countries had to come up with units which measure different things like length, which is meter, or we use inches or feet, or mass. In our country, we use a lot of pounds, but you can hear grams, or time is in second, or how much stuff you have in an area called a liter. So what we have is we have units that measure different things. And what we're going to do today is learn how we convert within the same type of unit. So when we get started, we have to use SI units. SI units, as I've just mentioned, are a system of international units that countries collectively have agreed upon to use, so that if I do an experiment over here in this country, I can easily reproduce it in this country. I know some of you guys have noticed that in Mars we have orbiters and we have rovers that are on Mars investigating if there was life on Mars and finding water. Well, the first orbiter that went around Mars actually burned and crashed because people were using one set of units like inches and someone was using other set of units, centimeters. So it's important you use the same units because you could lose $1 billion, as we did. NASA lost $1 billion when someone wasn't keeping track of what type of units. Both of these measure length, but they have different sizes. In fact, there are 2.54 centimeters, cm there, that should be a cm, for every 1 inch. So gosh darn it, if you're measuring inches, you're going to have too many centimeters. So what we're going to do is we're going to use something called the metric system with these units. Now, why do we use the metric system? Well, the metric system is nice and clean. Let me explain a little bit. Okay, we know in our current English units, which are really messy, we know that 12 inches equals 1 foot. We know that 3 feet equal 1 yard. And how many feet equal 1 mile? Well, some people would know the number. I believe it's 5,000 and something. I don't have that number on the top of my head. But how do we go from inches to miles? Is it an easy conversion? No, it's not. We'd have to use different numbers. In the metric system, which started with the meter, someone actually went and measured the Earth. And from measuring the Earth from the equator to one of the poles, they measured a distance, I believe, that was 1/100,000th. And they come up with a meter that was based on the Earth. Now, certainly I don't care if you don't know the details, but what's nice about using meter, okay, as a unit of length, and in the metric system, 1 meter, or we can have several of those meters. For instance, if I have a decameter, that means I have 10 meters. If I have a hectometer, I have 100. If I've got a kilometer, I've got 1,000. Notice I'm using these as my suffix. The word in front is telling me how many of them. Notice this has the 1. So if you notice my arrow here, if I'm using meter as the SI unit, that's the unit that all countries have agreed upon to use in calculations and scientific experiments, if I put that here as the 1, so if you put a meter here, and you say meter, it implies 1, these are the other words that go in front. So if I say kilo, and I change this to meter, right? The kilo tells me that I have how many? 1,000. Kilo tells me 1,000 of these single meter units. Now, the metric system is nice because if you notice, I'm going from what? I'm changing by tens. When I went from inches to miles, I'm changing by all kinds of crazy numbers. So it's really nice to do by changing by tens. Now, not only can I get bigger, I can get smaller. So if I have a meter, I can have 0.1 of a meter. Now, if you're not really aware of what 0.1 mean. 0.1 means 1/10, 1 over 10. So if I have a tenth of a meter, slice a meter up into 10 single units, and I have one of those, I'm called a decimeter. That means 1/10 of 1 meter. And if I'm smaller, centa is 1/100th. Another way of writing 100th is 0.01. And I'd write centa for 1/100th of a single meter. So if I get really small, I have milliliter or millimeter. That's what? 1/1000th. And again, 0.1 or 1 over 10, or 0.01 or 1 over 100, or 0.001 is the same number. Now, of course, there's another way I can write this. Okay, and I'll just change the color because I can. Let's do it magenta. I can write this one as 10 to the negative 3. I can write centimeter as 10 to the negative 2. It's the same thing as 0.02. I can write this one as 10 to the negative 1. The number 1 for the meter would be just 10 to the 0. Believe it or not, that equals 1. Now it's getting bigger, so we use positives. 10 to the 1, 10 to the 2, and 10 to the 3. So these are exponents, base 10. All right? If you notice, they're changing by tens. So if I go from one to the other, I'm just basically moving a decimal place, changing how many zeros or how many decimals away. All right? So for instance, it's very simple to convert. Let's think about this for a second. If I have 1,000 centimeters, how many meters is that? Notice they're both units of length. How many meters is that? Well, think with me for a second. For every 1 meter, I have what? I have how many centimeters? Think with me for a second. A centimeter means what? 1/100th of a meter. All right? So doesn't that mean I need 100 of them to equal 1 meter? Yeah, it does. So if I have 100 centimeters, think about your money. If I have 100 cents, cent means 1/100th, right? A cent is 1/100th of a dollar. So if I have 100 cents, don't I have $1? Now the dollar would go here. Now we don't talk about dollars as kilo dollars, okay? But you get the idea here, okay? So this is how it works. So obviously of 100 centimeters a meter, 1,000 is going to be 10 meters. Now if you don't see that, I'm going to show you how we do it, okay? So we're going to convert from one unit of length to another. But before we do that, I want you to totally understand, we have to pick the SI unit we're going to use, okay? So we're going to use meter here, and we're plugging it in. If I was looking for how much mass something weighs, or how much mass it has, I would put gram in here, second in here if it was for time, and volume. So you have to understand, we're talking about units of length, so we're going to put meter in here. We're going to stuff the SI unit right in here. That's important. And then once we understand that, then we're going to change the what? The prefix in front. So let's just go do a problem here. Okay? Let's go back to that initial problem so we can see it again. Let's take a 1,000 centimeters. I'm going to always write the unit and information given to me. It's a good thing when you're given a problem, write what's given. So I'm given this. Okay? Now, I want what? I want meters. Let's say I want to convert my centimeters to meters, or my cents in my pocket to how many dollars I have. All right? So let's see what we're going to do here. So I'm going to white some stuff out, get myself some space. Let's do it up here. Okay? And let's get small. So I get 10,000 centimeters. And I want to convert that into some number of meters. Okay, so what am I going to do? Well, the way to do this, and I call this factor label. Okay, I'm going to show it the first way. I'm going to times it by something called a converting factor. All right, if you notice, centimeter is the unit given. I want to get rid of that. And if you're going to cancel stuff out, you should know that centimeter over centimeter equals 1. They would cancel in math. So I want to put centimeter in my converting factor on the bottom. Since I want meter, it would go on top. And the basic way to do this, the basic way to do this, all right, is to take your value that's given, all right, I'll just write it here, and you're going to times it by a converting factor where you put the given unit on the bottom and the unit you want goes up top. And what's going to happen is the given will cancel and you'll get what you want. Look what I have here, party people. I want meter. So I'm going to put centimeter on the bottom. Centimeters cancel and I'm left with meter. But it's not that simple because I have to use a converting. I have to use a converting number. Remember I told you 1 inch equals 2.54 centimeters? We have to combine a converting factor. Well, I know this. Centimeter is smaller, right? It's 1/100th of the meter. Put the meter here. All right? Now, if it is 1/100th of a meter, okay, don't I need 100 of them to equal 1 meter? And if you don't like that, how many places away is it? It's 1, 2. How do I know that? I just did it. 1, 2. So it's 100 times different. All right. So I know it's a 1 equals 100. It's a 1 to 100 different. This is 0.01. This is 1. It's a 1 to 100. Now, who gets the number? Well, who is bigger, meter or centimeter? Well, meter is 1, right? And centimeter is what? 1/100th. So the bigger unit is a meter. So I know the smaller number should get the bigger unit should get the smaller number, and the smaller unit should get the bigger number. And I'm going to explain that. I'm going to explain that. So 1 meter equals 100 centimeters. All right. Now, how in the world does that make any sense? How can I have something like that? Well, think about this for me. Take my body and let's measure the science lab. Okay, and we're going to take my body and we're going to measure. And let's just say it takes, I don't know, many Grodzkis to measure the science lab. Let's say it takes 1, 2, 3, 4, 5. So the science lab is 5 Grodzkis in length. Okay, and we'll just call it GR. Let's take someone else in the room. Any student I have, which is going to be what? Smaller than me. Their unit of length is what? Definitely shorter or smaller. I'm longer than most people. Doesn't it make sense the smaller unit, you're going to need a lot more of them? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, let's make these Camerons, okay? So it takes 9 Camerons to equal 5 Grodzkis to measure the same thing. Grodzki is a bigger unit, so it gets a smaller number. Cameron is a what? Smaller unit, needs a bigger number for them to equal the same thing. Meter is a what? Bigger number, bigger unit, so it gets a smaller value. Centimeter is smaller than a meter, 1/100th, so it needs a bigger number. So the answer is 10,000 times 1 divided by 100, okay, and you get the answer here to be 100 meters. Okay, let's clean this up again. So the answer, my friends, would be 100 meters. Right? 10,000 times 1 divided by 100, and you get 100 meters. Let's do another. In fact, let's do number 1. Number 1 says I have, and let's white this out, make some room here. Number 1 says I have 25 hectometers. So 25 hectometers, I put my 25 here. That's my unit. I'm sorry, my number. My unit is hectometers. I'm just going to put HM, okay, as my abbreviation. You're allowed to do that. And notice a number without a unit means nothing at this point. And now I'm going to convert this into meter, little m. So I have HM. I want to get rid of it. So where does it go? On the bottom. Now what's the ratio here? Hecto means 100, meter means 1. There's 100 of these. Is it 100 hectometers equals 1 meter? Whoa, whoa, whoa. That wouldn't work out too well. Who is the bigger unit? Hecto is bigger. Who is the bigger unit here, Grodsky or Cameron? So certainly the bigger unit is the hectometer. And what's the difference between a hectometer? The difference between a hectometer and a meter. Oops, don't want to do that. What's the difference between a hectometer and a meter? 2 jumps, or 100. Remember, hecto is 100. So for every 1 hectometer, there's 100 meters. I put the what? I put the smaller number next to the bigger unit. The what? Smaller number with the bigger unit. And I put the larger number with the smaller unit. It takes 100 of these. All right? 100 of what? 100. It takes 100 of the meters to make a hectometer. It takes 100 meters to make a hectometer. Okay? And that's how you keep those things straight. You're going to cancel a hectometer. 25 times 100 gives me 2,500 meters. All right, and that's your answer. Without the unit, you'd get this wrong. So the answer, my friends, down here is 2,500 meters. Without the meter, it's wrong. Without the unit, the number makes no sense. Mr. Grodsky, how tall am I? What if I said to you I'm 1? 1 what? I'm 1 Grodsky? What if I said 237? 237 what? Numbers without units don't mean anything. So from right this point forward, from this moment on, as Shania Twain would say, you need to have a unit. All right? And that's how we do it. Now, there's another way to do this. I almost don't want to show you, but I will. If we're starting with a hectometer, okay? If you're starting with a hectometer, right here, it's your starting place. What's given to you is your starting place. And I'm getting smaller, smaller to my meter. Remember, meter goes in here. All right, meter belongs right here. That's where your suffix, a gram or volume. I'm getting smaller by 100. I can take 25, find my decimal point, which is right after the last number, and I can jump 2 places and notice that's 2,500. It's the same answer, but you got to put the unit in. Mrs. Zagrodsky, why don't you just show me that? Well, because you're responsible for doing this. This is called the factor label method. Dimensional analysis, but factor label. You're responsible for showing the work and doing that. Okay, that's why. Okay, so what if we do number 2 together? Why don't you try number 2? Let's not do number 2. I'm looking at it and I want to move around here. Let's do something smaller, like decimeters. Well, let's do number 4 together before I do that. Okay, so let's do number 4. So number 4 is decimeters. So let's get rid of this. Remember, if you want to see this, just rewind me. You can always stop Grodsky and rewind Grodsky. Okay, so here we go. All right. So here we go. So I'm given what? 10 decimeters. I'm given 10 decimeters. So I write what's given, 10 decimeters. I'm just going to abbreviate. What am I converting to? Well, in this unit, this worksheet, I convert to meters. So I'm going to go to meters. Where does decimeter go, on top or the bottom? I want to get rid of it to get rid of the unit given to the unit I want. That's correct. Decimeters go on the bottom. Meter goes on top. You've got to be able to set it up this way. Now, what's the numbers? Well, if you notice, we're jumping where? From decimeter, we're starting here, and we're going back. So I'm going from a small number back to a big number. But more importantly, I'm converting my decimeters, which is a smaller unit than a meter. Anything this way gets smaller. Look at these numbers. Anyway, this way gets bigger. Okay? So I get rid of decimeter. I know there's one jump from decimeter to meter. This differs by just 1/10. It's nice about the metric system. It's just moving decimal places, really. So who's the bigger unit? The bigger units are to the left. Meter. For every one of these, there's 10 of these. Remember, deci is a part of a meter. So because the meter is bigger, it gets the smaller unit. The smaller unit gets the bigger number, like we did over here. Okay? So for every 1 meter, there's 10 decimeters. And that's the biggest mistake people have. They can't figure out the numbers. Decimeter cancels, 10 times 1 divided by 10. Put that calculator, and you get 1 meter as your answer. Make sure you put the unit. Okay? Now, of course, you could say, oh, 10 decimeters. All right. And I'm going to go to meter. Oh, I'm moving this way to the left. I'm getting bigger by how many jumps? By 1 jump. Here's my decimal places here. It moves 1 place, and I'm left with 1. My number, my numerical value is getting smaller because I'm converting to a bigger what? Unit. Remember, bigger the number, smaller the unit. Smaller the number, bigger the unit. It all makes sense. You just don't want to move decimal places. Getting the answer is great, but you have to do the factor label. So what I'm asking you to do is please finish the rest of the worksheet. For homework, look at the key. You're responsible for this. Now, I will say this. You need to remember, a nice way to remember these little breakdowns here is the following. So how do I memorize this? Well, some of this is given to you in your reference table, but you can remember this as King Henry died drinking cat milk. And we put the suffix in the middle. So that's one way to remember these breakdowns. Okay, good luck.